today we're going to cover Chapter 9, Section 2, and we're going to be covering special right triangles. Now, these special right triangles are going to be very important because they're going to come up again later on in another chapter. You will also cover special right triangles when you take Algebra 2 and you cover the unit circle. Because what you're going to be doing is you're going to be covering a unit circle, and then from that, within the triangle, within the circle, you're going to be pulling out special right triangles. So it'll be very important that you find a way to memorize the relationship of the sides of these special right triangles. But before we get into the lesson, let me do a little bit of Algebra 1 review, and I'm going to talk about rationalizing the denominator. So when you rationalize the denominator of a fraction, what we're doing is trying to get rid of a square root that's in the bottom of your fraction, because it's against the math laws or the math rules that you can never ever leave a square root in the bottom of a fraction. So for example, let's say after you did the problem and you ended up with 18 over the square root of 3. This would not be a simplified fraction. We need to make that square root of 3 a perfect square to get rid of the denominator. We cannot leave a square root in the bottom of a fraction. So the process of getting rid of that square root is called rationalizing the denominator. And what we do is our goal is to make the square root of 3 become a perfect square. And generally the easiest way to do it is multiply it by itself. Because if you remember when you do your factor trees and breaking down your square roots, whenever you have a pair of the same square root, that just comes out of the square root symbol. So what would come out of the square root of 3 times the square root of 3 is just a 3. Now, if you think about it and you multiply it, 3 times 3 is 9, and then the square root of 9 is 3. However, for the numerator, I cannot multiply something that's outside of a square root symbol with something inside, so I would just leave them side by side. And then now, if your fraction can be reduced by dividing or simplifying outside numbers with outside, I could actually simplify the 18 and the 3. I can divide them both by 3, make this a 1, make this a 6. So my final answer here is 6 square root 3. Let me do another one, because what we're going to be working with in this chapter or in this lesson are the square root of 3 and the square root of 2. And these numbers are going to end up in our denominators. So let's say I had 7 over the square root of 2. Again, I can never ever leave a square root in my bottom of my fraction, so I need to multiply both the numerator and the denominator by the square root of 2, because whatever you do at the bottom of the fraction, you do the top. Essentially what I'm doing here, this is actually equivalent to 1. So really all I'm doing is multiplying it by a 1, but it is going to change the way it looks. So for the numerator, I would just put the 7 and the square root of 2 side by side. And for the denominator, because I have a pair of square root 2's, the 2 comes out. Nothing simplifies here, so I would just leave it 7 square root 2 over 2. Let me do one more. Let's say I have 8 over the square root of 2. Again, I have to rationalize. Got to get rid of that square root 2. So multiply both the numerator and the denominator by the square root of 2. And then the denominator just becomes a 2. And then again, I can simplify 8 divided by 2 or divide them both by 2. And I'm left with 4 square root 2. So be able to rationalize the denominator of your fraction anytime there is a square root left in there after we have simplified something. So our first theorem, or our first special right triangle, is called the 45-45-90 triangle. And in a 45-45-90 triangle, the hypotenuse is going to be the square root of 2 times as long as each leg. So in my picture here, these two letter A's here, the two sides forming the right angle, this is a leg, this is a leg, and this is my hypotenuse. The hypotenuse is always across from the right angle. So these are two congruent legs. This is actually an isosceles right triangle because the two legs are the same. Because of my converse of my base angles theorem, since these two angles are congruent, then the sides across from them would be congruent side lengths. Now, let me go ahead and add some numbers to my picture to show you how we're going to calculate the different side lengths. So let me go ahead and you can either add the numbers to the picture or redraw it. So this is my right triangle here, and this is A, this is A. This is going to be A times the square root of 2. So let's say I told you that A equals 8. Well, if it asks you to find all three sides, then this other side over here that's labeled as A would also be 8. And then the hypotenuse, all you do is take what A equals, put it there, and then add square root 2. And this is how we can find the other two sides when it's a special right triangle, more specifically a 45, 45, 90. Now, the next special right triangle we're going to talk about is the 30, 60, 90. And that one is going to involve the square root of 3. Now, to keep, I guess, track of which one gets the square root of 2 and which special right triangle gets the square root of 3, I sort of think of this as having two of the same angles. So this is my way of remembering the 45, 45, 90 gets the square root of 2. When we take a look at the 30, 60, 90, it's going to have three different angles, so that one's going to involve the square root of 3. But we're going to see that coming up. We're going to do an example using this theorem. Notice this time they're not using the variable A. You don't always have to memorize it as an A. That variable could be anything. So if they're using the variable X, then this 6 is actually equal to X times the square root of 2. So the two legs, and I can tell that this is a 45, 45, because I have two congruent sides, then this tells me I have two congruent angles. The base angles would be congruent. So what I can do is take 180, the sum of the three angles, subtract out the right angle. That leaves me 90 for the other two. Divide by 2, and each one of these angles is 45. So this is how I know I'm working with the 45, 45, 90. So if the two legs are X, and the hypotenuse is supposed to be whatever X is with square root 2 behind it, to figure out what X is, I need to solve this algebraic equation. So I'm going to be setting X times the square root of 2 equal to 6, and I need to solve for X. So to do that, I'm going to divide both sides by the square root of 2. The square root 2's cancel. It frees up X. So X is equal to 6 over the square root of 2. Now, before I started the lesson, I told you that we can never, ever leave a square root in the bottom of a fraction. So we need to simplify this fraction by rationalizing it. So what I need to do is multiply both the numerator and the denominator by the square root of 2. This ends up giving me 6 square root 2. And I've made a pair of square root 2's. So this comes out as a 2. And then I can also simplify the fraction a little bit more. and this would become a 1, and this becomes a 3. So my final answer here for the 2 legs is 3 times the square root of 2. So x is equal to 3 square root 2. And then this one would be 3 square root 2. You may say, well, wait a minute. I thought the hypotenuse was supposed to have a square root of 2. How could the hypotenuse be an integer? Well, whenever you multiply a leg that has the square root of 2 times the square root of 2, it will make that hypotenuse an integer. So let me work with it the other way, giving you the leg instead of the hypotenuse. So let me just add an example here. I'm just going to redraw the same picture. Add in the right angle. And again, put x, x, and then this is x square root 2. But this time, I'm going to tell you that x is equal to 3 square root 2. So then this x would also be 3 square root 2. And now to find the hypotenuse, you're going to take what x equals, 3 square root 2, and then put this square root 2 behind it. And this is how it'll turn into 3 times 2, and that's how that hypotenuse becomes a 6. The next theorem is, or the next special right triangle is called the 30, 60, 90 triangle. And in this triangle, the hypotenuse is going to be twice as long as the shorter leg, and the longer leg is going to be the square root of 3 times as long as the shorter leg. Now you may say, well, how do I know which one's the shorter or the longer? Again, you can never go by what it looks like, but what we can go by is the angle measures. So remember, in a prior chapter, we learned that the longest side of a triangle is always across from the biggest side. So my biggest angle is 90, so this is going to be my biggest side, and the biggest side of a triangle is called the hypotenuse. Now, to figure out which one is the shorter leg and the longer leg, this is where I look at the angle measures. So my smaller angle between 30 and 60 is the 30. So the side across from the 30 is going to be A, and this is going to be my shorter leg. And then out of the two angles, the bigger between 30 and 60 is the 60. So this is going to be my longer leg, and it's equal to A times the square root of 3. So what you're memorizing is the side that is opposite to the 30 is equal to A. This is the shorter leg. This is everything I just wrote on the picture. And then opposite to the 60 is going to be equal to A times the square root of 3. And again, you don't have to use the variable A, because in the homework they're going to use different letters. Then the last one, opposite, and this is longer leg. And then opposite the 90 is going to be whatever the shorter leg was times 2. And this is your hypotenuse. So let me go ahead and add some numbers. So this is what you're memorizing. Again, some people memorize this as the 1, 2, 3 triangle. Again, the way that helps me to remember which one gets the square root of 3, this one has 3 different angles, so I know it's involving the square root of 3. The other one had 2 of the same angles, so that one gets the square root of 2. Whatever tricks are going to help you, you just need to memorize. So let's say I redrew the same triangle, add in my 90 degrees, my 30, and my 60. And let's say I give you that this side over here, A, is going to be 7. So we know that the side across from 30 is A. The side across from 60 is going to be A times the square root of 3. Well, if A equals 7, then I just put 7 and then the square root of 3. And then the hypotenuse is going to be 2 times A. So if A was 7, 2 times 7, and my hypotenuse is 14. This will be the given, and then from there, you're going to be able to find the other sides. So they're going to give you some angle measures and one of the sides. And then from there, you can find the other two. So in example 2, notice they're giving me one side and two angles. They gave me the right angle and they gave me the 60. I need to figure out what this angle is. You're going to eventually get used to seeing, as soon as you see it's a right triangle and one of the angles is 60, you're going to automatically know that this missing angle here is going to be 30. But if you didn't catch right away, what you would have done is you would have done 180, and you could first add the 90 and the 60, get 150, subtract that from 180 using your triangle sum, and that missing angle was 30. Now that we have the 3 angles marked, I can go now and I can go back and show you what X and Y are supposed to be in terms of that 5. So remember, the side across from the 30, this is where A is. The side across from the 60, this X up here, this is supposed to be whatever A is with square root 3 behind it. And then the side that is across from the 90-degree angle, this is my hypotenuse, and this is 2 times A. Well, if A equals 5, then my hypotenuse is going to be 2 times 5, and Y is going to equal 10. X, all I have to do is take what A equals, put it here, and then put square root 3 behind it. And that's what X equals. So it's just a matter of memorizing where everything is located and then plugging it in to get the lengths of the sides. Now, let me add 2 more. I'm just going to add some different numbers just to give you some more practice. So let me draw another triangle here. Sitting the same way. So I'll put a 60 here. It's not always going to be sitting this way. It could be turned up. So let's say this time I give you that the length of this side is 2 square root 3. Now, what you need to recognize is that this side across from the 30, this is A. The side that's across from the 60, this is supposed to be A square root 3. And the side across from the 90, 2 times A. My A value is 2 square root 3. To get the side across from the 60, I need to take out this A and replace it with 2 square root 3. Now that side still also has square root 3. Recognize that you've got a pair of square root 3's, so that 3 will come out of the radical. So this side is actually going to be 2 times 3, and this side length is going to be 6. Over here, 2 times A, well, A was 2 square root 3. Multiply the 2 outsides, and the hypotenuse is 4 square root 3. So the 3 sides of this triangle are going to be the 6, the 2 square root 3, and the 4 square root 3. To be able to multiply with radicals and rationalize them. Let me do one more. And then we'll bring in our quadrilateral. So here again, same thing. What you're looking for is where the 30 and the 60, 90 are located. So this one is A, this one is A square root 3, and this one is 2 times A. So let's say this time I give you the length of the hypotenuse. So let's say I tell you that this side has a length of 18. Well, in order to get A, we need to solve this equation. So divide both sides by 2, and A equals 9. So then I put 9 over here, and then this side is just going to be 9 with the square root 3 behind it. So once you memorize the relationship of all the sides, going back and filling them in and finding them is a lot easier. The next one is telling us that the diagonal of a square has a length of 6, and it's asking us to find the perimeter of the square. So let me go ahead and draw it in. So let me draw a square. There's my square. Back in the quadrilateral chapter, we learned that a square has 4 congruent sides. It also has 4 right angles. It also has diagonals that are congruent. So it doesn't matter if I draw that diagonal or the one going this way. I only have to draw one of them in. And it told me it had a length of 6. One of the other properties I know about the diagonal is when I learned about the rhombus, I know that the diagonals of a rhombus bisect opposite angles, and all squares are rhombuses. So this tells me that this angle has been bisected. So if it's 90, then each one of these is now 45 and 45. And now what I'm going to work with is just this little, or one side of it, and it's a 45, 45, 90 right triangle. So I'm just going to pull off one of the sides, or one of the triangles. So if I go ahead and redraw those legs and my diagonal, that diagonal was 6. This is the right angle, and then I have the 45 and the 45. So remember, at the beginning, the very first theorem we learned is that when you have the two congruent 45-degree angles, these are also congruent. And then this could be A, this could be A, and then this 6 is going to be equal to A times the square root of 2. So now to find A, which is actually the side of my square, I need to solve this equation. So A times the square root of 2 equals 6. Divide both sides by the square root of 2. It cancels. And then I'm left with A is equal to 6 over the square root of 2. Can't leave that radical in the bottom. I must rationalize. So multiply top and bottom by square root 2. The numerator, I just put it side by side. And then the pair of square root 2's, it just comes out. And again, I can simplify the 6 and the 2. 6 divided by 2 is 3, square root 2. So A is 3 square root 2. Well, if you recognize that A is actually the side of my square. Now, the question did not ask me to find the side of the square. It asked me to find the perimeter of the square. So for this one, you can do two things. Whenever it's a square, the perimeter is 4 times the side length. Well, if my side length is 3 square root 2, I'm just going to times it by 4, do the outside numbers together, and the perimeter is 12 square root 2. Now, the other way that you could have calculated the perimeter is add up all the sides. So you could have also done 3 square root 2 plus 3 square root 2, plus 3 square root 2, plus 3 square root 2. Whenever you add numbers that have a square root in them, treat the square root like a variable. You don't add what's under the variable or under the radical, you just add the coefficients. So pretend like this was really saying 3x plus 3x plus 3x plus 3x, and you would have gotten 12x. This is the same idea with the radical. All we add are the 3's, and then we just leave the square root of 2. And that would be another way that you could have done the perimeter. It's a lot easier to just do this. Now, I know this question had only asked for perimeter, but let's say it said find the area. So if the question would have said find the area of the square, then what we would do is area is either, think of it as base times height, or just side to the second. So my base and height are the same thing. So for the area, it would be 3 square root 2 times 3 square root 2. 3 and 3 is 9. The pair of 2's, it comes out. So the area here would be 18. And this didn't have any units on it, so you could actually say square units. And for the perimeter, it would just be units. So in the homework, you're actually doing a square, and it's asking you to find the area. So be able to do both. All right, last example. They're talking about an equilateral triangle. So let me go ahead and draw in my equilateral triangle. So there's my triangle. Know that when it's an equilateral triangle, all 3 sides are the same. I also know that when it's equilateral, it's also equiangular. So if I know that all 3 angles of a triangle add up to be 180, and if I divide them by 3, each angle of my triangle is going to be 60 degrees. Now, they said that the altitude, so my altitude would come straight down from that top vertice, and it would be the perpendicular segment. Now, just like before in the previous slides, whenever it's an isosceles triangle or equilateral, this altitude is also a perpendicular bisector, and it's also a median. So this also tells me it has split this side of the triangle into 2 congruent pieces, because it would be the midpoint right here. So now, what I can also see is this altitude also has bisected the 60 degrees. So each side would be 30. So now what I'm working with here is I'm going to work with one side of my equilateral triangle, and I'm going to pull this off, and it's actually a 30, 60, 90 right triangle. If I go ahead and redraw it and add in my angle measures, 60 and 30, the right angle, and they gave me the altitude. The altitude was 5. So this is where I need to memorize the relationship of the sides. So remember the side across from the 30. This is where A would be located. The side across from the 90, the hypotenuse, is 2 times A. And then the side across from the 60 is A square root 3. This is going to be the algebraic equation that I need to solve and get the value of A. So I'm going to take A times the square root of 3 equals 5, solve it for A. So I divide both sides by square root 3. It cancels the square root of 3. And now I'm left with A is equal to 5 over the square root of 3. Again, I cannot leave that square root of 3 in the bottom. I need to make it a perfect square by rationalizing. and this gives me 5 square root 3 over 3 is my value of A. And now for 2A, I take 2 times 5 square root 3 over 3. All I can do here is multiply the 5 and the 2. Nothing simplifies. So my hypotenuse is 10 times the square root of 3 over 3. Now, this hypotenuse is also the side of my equilateral triangle. So this side is also 10 square root 3 over 3. So is this side, and so with this side over here. So now to find the perimeter, all I have to do, since they're all the same, is to multiply 3 times 10 square root 3 over 3. You can put a 1 there. This is going to simplify. This becomes 1s. And then my perimeter is 10 square root 3. And these would be units. Now, the other way you could do it is take 10 square root 3 over 3 plus 10 square root 3 over 3. And notice when you add fractions, you need a common denominator. It already has a common denominator. My common denominator was 3. And then I just add the coefficients. And I would get 30 times the square root of 3. Simplify it. The 3 and the 30 simplify. And my final answer, 10 square root 3. Same answer I got when I just multiplied. I'm going to also do this same question. I'm going to do area of it. So let's say they wanted, and it didn't ask for it, but let me just show you. So let's say they said to find the area of the triangle. So that's 1/2 base times height. So my height is 5, and I just found the base. It's the 10 square root 3 over 3. So let me plug my numbers in. So area equals 1/2 10 square root 3 over 3 times the height. I could simplify here, make that a 5. And now the only thing I have left to multiply is the 5 times 5. I could put a 1 here. So 25 square root 3 over 3. And these would be units squared, or square units. So be able to do perimeter or area. On the quiz on Thursday, you are going to be leaving your answers exact. In other words, in simplest radical form. So if you try to use your calculator and you hit that square root button, you're going to get it wrong. Everything needs to be in simplest radical form. You can use your calculator, however, it's not going to help you very much. So your homework is the 9-2, and also complete that 9-1 warm-up. We're going to submit that to Canvas as well.